So today we're looking at solving systems of equations by elimination. We've done this in the past, and this is kind of the last go round before we take a review and then quiz. So, how do I solve systems of equations is my essential question. My learning intention: I am learning to solve systems of equations. You've got two warm-up questions. The first one you solve by graphing, and the second system you solve with substitution. So pause the video now and see if you can do those two warm-up questions. Well, I do hope you tried to do these two on your own. So as we're looking at the first system, where do we begin? At -2. How do we move? 1/2, which is up 1 and right 2. So I start with -2. I go up 1 and right 1, 2. I now have a second point and I can graph. Okay, where do I begin on the second one? This time I begin at +3. How do I move? -2, which means down 2 and right 1. Here's 3. I go down 1, 2, right 1. And I am now ready to draw my line. Remember that the solution is the point where they intersect. The point where they intersect is a point 2, -1. I could substitute in and make sure it works on both. 1/2 times 2 is 1. 1 minus 2 is -1. So I've got the 2, -1. -2 times +2 is -4. -4 plus 3 is -1. That's how you check to make sure your solution is correct. For the next one, we're going to solve using substitution. To use substitution, you have to have one of the two equations set equal to either x or y. This is where you have to think. If I set the first one equal to x, then all I have to do is add 3y to both sides. Once I do that, I can substitute into the second equation. So, x minus 6y is equal to -11. I'm going to add 6y to both sides. Now, x is equal to 6y minus 11. I can substitute that into the second equation and then solve for y. So as I substitute in, 3 times 6y minus 11 plus 2y is equal to 7. Distribute. 3 times 6y is 18y, minus 3 times 11 is 33, plus 2y is equal to 7. Combine your like terms. 18y plus 2y. 18y plus 2y is 20y, minus 33 is equal to 7. Now how do I finish solving? I will add 33 to both sides. $20y is equal to 40. Divide both sides by 20. And y is equal to 2. But I still have to find x. So I'm going to go to where I've solved for x. X is equal to 6y minus 11. But y is 2. X is equal to 6 times 2 minus 11. That's a really bad 11. X is equal to 12 minus 11, and x is equal to 1. So this solution is a point 1, 2. So as I check, okay, 1 minus 6 times 2 is 12. 1 minus 12 is negative 11. 3 times 1, 3, plus 2 times 2, 4. 3 plus 4 is 7. So that is the solution to both of those equations. But what about elimination? How do we use elimination? Well, we have to create those opposites. So if I'm looking, I've got a 2 and a 5, I've got 3 and a 4. I cannot create opposites by just scaling one of the equations. I have to scale both. Now my question becomes, do I want to multiply by 2 and 5 because that's what I'll have to do to get opposites for the x, or by 3 and 4, which is what I would do to get opposites for y? I can think one step further. This is negative, this is positive. So I will be multiplying both of them by a positive number. These are both positive, so one would have to be multiplied by a negative number. I think that I will use the 5 and 2. The top row has to be multiplied by the coefficient of the second row on the x on the second row. So this has to be multiplied by 5. Then the bottom has to be multiplied by the positive coefficient of the first row. So I'll multiply this by 2. 5 times negative 2x is negative 10x. 2 times 5x is positive 10x. Those are my opposites. So as I get started, 5 times negative 2x is negative 10x, plus 5 times 3y is 15y, equals 5 times 7 is 35. Now for the second row, 2 times 5x is 10x, plus 2 times 4y is 8y, is equal to 2 times 17, which is 34. Now I'm ready to add straight down and eliminate my x's. Negative x plus negative 10x plus 10x is 0 x's. 15y plus 8y. What is 15 plus 8? If you said 15 plus 8 is 23, that would be correct. 23y is equal to 35 plus 34 is going to be 69. And now let's solve. We have to divide both sides by 23. And y is equal to. This goes in 3 times, so y is equal to 3. But we still have to find x. Which of the equations do we want to use? it really doesn't matter. We can use the first equation, the second equation, either one of these two scaled equations, and we'll substitute in 3. Let's use the first equation. Negative 2x plus 3y is equal to 7. Substitute 3 in for y. Negative 2x plus 3 times 3 is equal to 7. Simplify. Negative 2x plus 9 is equal to 7. Now I'm ready to solve. I will start out by subtracting 9 from both sides. I've eliminated it there. Negative 2x is equal to negative 2. Divide by negative 2. And x is equal to 1. So what is my solution? My solution is the point 1, 3. How do I check? Well, I substitute back in. So I've got negative 2 times 1 is negative 2, plus 3 times 3 is 9. Negative 2 plus 9 is equal to 7. For the second one, 5 times 1 is 5. 4 times 3 is 12. 5 plus 12 is 17. I've checked with both of my equations. That is my solution. For the next one, pause the video and see if you can get it set up. Once again, you're going to look at your coefficients of x and your coefficients of y and decide which one you want to use to create those opposites. These are both positive. These are a negative and a positive. Which one's easier? I don't know. Pause the video and try. I do hope you tried. For me, I would use 3 and 5 because they've already got opposites, so I will be multiplying by a positive number. So the coefficient down here is 5, so I'll multiply the first equation by 5. The coefficient for y on the first one is negative 3, so I'll multiply by a positive 3 because I do not want to get rid of the negative sign. Now what does it look like when we finish this up? 5 times 6x is 30x. Minus 5 times 3y is 15y is equal to 5 times negative 15, which is negative 75, I believe, but I will always check. It is negative 75. Okay, for the second row, 3 times 4x is 12x. 3 times 5y is 15y is equal to 3 times 11 is 33. I've eliminated my y values. 30 plus 12 is 42x is equal to negative 42. Divide both sides by 42. And x is equal to negative 1. I know what x is, now I have to find y. Which one of these am I going to use? I actually think I'll use the second one here, which is 4x plus 5y is equal to 11. 4 times negative 1 plus 5y is equal to 11. Simplify. Negative 4 times negative 1 is negative 4 plus 5y is equal to 11. I can solve now for y. I'll add 4 to both sides. Five y is equal to 15. Divide by 5. And y is equal to 3. So my solution is the point -1, 3. How do I check? How do you use substitution? 6 times -1 is -6. 3 times 3 is 9. -6 minus 9 is -15. 4 times -1 is -4. 5 times 3 is 15. -4 plus 15 is 11. I've checked both and it works. That is where the graphs of these two lines would intersect. So look at the next one. We always have to throw something in that's a little bit different, and this one's different because it has decimals. So you have to realize that sometimes it's not terribly hard to use decimals. As I'm looking, 1.5 and -3. Those are the coefficients of x. -0.75 and 4.5 are the coefficients of y. So if I do the coefficients of y, it's not very pretty. But if I do the coefficients of x, I know that 1.5 times 2 is equal to 3. So all I have to do is multiply that first equation by 2. One 1.5 times 2 is 3. 3x minus 0.75. Well, think of what 75 cents plus 75 cents is. That's $1.50. 1.5y is equal to, I've got $5.25. If I double that, I have $10.50. I have created my opposites. -3x plus 4.5y is equal to -7.50. My x values are gone. -1.5 plus 4.3 is 3. 3y is equal to 10.5 minus 7.5 is 3. Divide both sides by 3. And y is equal to 1. Now to find x. I think I will actually use this second one, because I think it's going to be a little bit easier. So, -3x plus 4.5 times 1 is equal to -7.5. -3x plus 4.5 is equal to -7.5. Now what? Well, the first step to solving is to subtract 4.5 from both sides. Negative 3x is equal to. These are both negatives, so I combine them with addition. 0.5 plus 0.5 is 0, carry the 1. 7 plus 4 is 11, plus 1 more is 12. So this is equal to negative 12. Last step is to divide by negative 3. And x is equal to 4. So my solution is 1, 4. You can substitute it back in to check the answer if you want, or just go on. If you're doing it on a test, you would want to stop and check your answer. Okay, the last one is a word problem. The Humane Society has 74 dogs and cats to be adopted. The number of cats is 10 more than twice the number of dogs. Write a system of linear equations that represents this situation. How many of each animal is up for adoption? So we know the total is 73, and that's both cats and dogs. The number of cats is 10 more than twice the number of dogs. Okay, variables. What do we want to use for dogs? So D is the number of dogs. And C is the number of cats. Now what? Well, we know the number of cats and dogs together is equal to 73. D plus C equals 73. But the number of cats is 10 more than twice the number of dogs. So my C is equal to 10 more than twice the number of dogs. Now, what are we going to use? Are we going to use graphing? Are we going to use substitution? Or are we going to use elimination? Well, in this case, I would use substitution because we can substitute the expression in for C. So, D plus 10 plus 2D is equal to 73. Combine your like terms. D plus 2D is 3D is equal to, or 3D plus 10 is equal to 73. Now we're ready to solve. Start by subtracting 10 from both sides. $3D is equal to 63. Divide by 3. And D is equal to 21. What does that mean? That means that there are 21 dogs. How do I find C? Well, I can plug it in here, or I can take 21 plus C equals 73. Then all I have to do is to subtract 21 from both sides. And C is equal to 52. So what does that tell me? There are 21 dogs and 52 cats that need adopted. So hopefully this was just a review and nothing new and exciting, and you're feeling comfortable solving systems of equations. So how do you know you're successful? You know you're successful when you can solve systems of equations using any method. Solving systems of linear equations. Please make sure to practice.